Hi, I'm Brian Goldblatt, and this is my lab observing the sound wave amplitudes and frequencies of the human voice. So a quick introduction to this lab. Sound consists of acoustic waves, and acoustic waves are a type of energy propagation that's just like a loading and unloading of a frequency, like a sine wave curve. And higher frequencies mean higher pitches, and higher amplitudes mean higher volume. So the number of vibrations made by a particle in 1 second is called the frequency, and the amplitude is the relative strength of sound waves transmitted from vibrations. And so how were we collecting these values? We used a DAC called the LabJack T4, which does signal sampling, which measures the real-world physical conditions and converts them into the digital values that we could be observing on our simple DAC displays that displayed the power spectrum and time history. The power spectrum showed us frequency and time history showed us amplitude, and we could collect our data via aux or mic connection to the DAC. So as you can see on this graph, when we were collecting data of microphone values versus aux values, we saw a relative response was the microphone response divided by the aux response, and we saw a roughly inverse relationship. As you can see, it models a y equals 1 over x graph roughly, and the reason that they aren't perfect is because there may have been mic placement consistency issues. The audio and equipment quality might not have been the greatest, and there was also background noise present. So my motivation for completing this lab, I was overall just pretty curious about how a voice box worked, and I also wanted to know my personal limitations on how high-pitched I could get my voice to go. So my approach for this lab was first of all, to keep the mic 6 inches away from my face so that I could control the volume of my sounds, because, the closer you hold the mic to your face, the louder something is going to be. And I recorded 5 personal pitches of my voice. I tried to keep them all approximately the same volume, again, so I could try to control amplitude as best I could, because I'm trying to focus on frequency. And I went from lowest pitch to low mid to mid to mid-high pitch to the highest pitch. And this is an example of the lowest pitch. And this is an example of the highest pitch. So I recorded these frequencies that I got from the power spectrum from these sounds, and these are my results. So the results I got, as you can see in this top graph, this was from the lowest pitch that I could muster. I had only one peak of about 700 hertz, and in my highest, on the bottom, you can see I had like 7 peaks, the highest of which got to about 2900 hertz. And as you can see, there is a clear similarity or a clear correlation between my own personal decisions of what my pitches of my voice are capable of and the number of frequency peaks that I observed from my recordings. So my conclusion from this experiment was that the human voice box operates on a very complex combination of different frequencies. It's not just one set frequency, especially when you get to higher pitches and higher amplitudes, even, as you could probably tell from my graphs that my amplitude modulation was not great. But voices tremble and change frequencies at lower frequencies, as I observed in the amplitude changes in my one pitch from my lowest pitch example. And I also found out that my personal highest possible pitch is probably around 2900 hertz.